In this video, we will be explaining how to adjust the preload of the axle shaft bearing cone of a John Deere 544H axle.
The bevel gear turns the crown gear, and coming out of the differential gives us a gear reduction of 2.6 to 1 ratio. Then, the sun gear is driven from the differential to the final drive. When the ring gear held and the planet carrier being the output, the gear reduction will be 4.8 to 1 in the final drive. If we multiply 2.6 by 4.8, we will get a total gear reduction of 12.48 in the axle.
Now we'll be explaining the procedure for inspecting the bearings. Take note of the condition of the bearing. Clean bearing with light oil or rubbing alcohol. Examine the condition of raceways, external surfaces, the amount of cage wear, and increase of internal clearance. Now compare the internal clearance of the tapered roller bearings to the axle shaft and the housing bushings. It is crucial for the components to operate as intended. If any of the following apply to the bearing, it must be replaced. Cracks in the inner or outer rings, the rolling elements or cage, flacking of the raceway or rolling elements, significant smearing of the raceway surfaces, ribs, or rolling elements, the cage significantly worn or rivets loose, there's rust on the raceway surfaces or rolling elements, major impact or brinell traces on the raceway surfaces or rolling elements, significant evidence of creep on the bore or the edges of the outer ring, discoloration by heat, or significant damage to the seals or shields of grease-sealed bearings has occurred.
Too much preload can cause excessive friction and therefore excessive heat. This can cause excessive wear and a complete failure of the axle.
Too little preload causes a lot of vibrations and a bunch of uneven movement, which also leads to excessive wear and a complete failure of the axle.
The adjustment of the preload on the axle shaft bearing cone comes down to adjusting and checking the baseline rolling drag torque, so checking the rolling torque when the bearing is loose, and the rolling drag over baseline torque, which is checking the rolling torque when the bearing is tight when the bearing is tightened by the retaining nut.